Welcome to learning how to use Rust with the FREE-WILi. Today we are going to install everything from scratch. The only assumption is that you have Visual Studio Code installed already. So to get started, we are going to install the Rust runtime. We can do that by going to rustlang.org, copy this command. We're going to proceed with all the defaults. Alright, Rust is now installed. We will have to restart the shell to actually make it work. Close out of the terminal and do a quick test. Do rust c, and you can see it's installed. FREE-WILi is using Wasm, and we need to install that target to compile the Wasm32. You do that by typing in rust up target add. There we go. Our next step is to install UV, and this is optional, but this will help the process for development and automatically uploading Wasm scripts to a FREE-WILi. So here we go. Here we can do copy this one. Everything's installed. Again, restart the shell. Alright, and then we are going to install the FREE-WILi Python package by doing uv install FREE-WILi. Oops, sorry. uv tool install. There we go. And then it installs FWI serial. And as you can see, I already have one connected to the computer. Alright. Now we have basic installation of Rust and UV and all of our FREE-WILi stuff. It's time to create a project. Close out of that. Alright. So now we're going to do cargo, new, my new project. Alright, and cd my new project, code. Say yes, trust the authors. Before we go any further, let's install some extensions specific to Rust to make our lives easier. Type in Rust. We're going to install a Rust analyzer. Append-I, if it'll actually type. And even better, toml. Alright, now that we have everything installed, we can go in here. We have our Hello World Rust project. Do cargo build. And we have an error. This error message is because we do not have a C compiler or linker installed. Let's go apt install, so let's install that. Yes. Let's try this again. There we go. And if we do cargo run, we can see hello world. So our project compiles. Currently this is set up for 64-bit on a PC. We need to now configure this to work with Wasm. In order to configure this with Wasm, we are going to create a new folder. It's going to be .cargo. And then inside .cargo, we're going to make a new file called config.toml. Then in here, we're going to copy a few things in here. Build target, this will set it to WASM 32 unknown. And then we have some flags here to set stack size and heap and all that, since we're in a constrained embedded environment. Then this runner flag right here, when we do cargo run, it will utilize FWI serial, the command that we installed earlier, and it will automatically upload and run the script. Now it's time to start setting up our project for our embedded environment. Let's see here. So I have a little bit of code here that we're going to copy and paste. We're going to specify no std and then no main. Wasm does not need a main function by default. We're going to use _start, and that's going to be our entry point where the program begins to execute. Right now this code will not compile because we're not done setting up our FREE-WILi header. So our next step is to add the submodule to our project for the header. Alright, the header is now included. In order to make this work and have Rust utilize and convert this, we are going to have to do a couple things. We're going to open our cargo.toml. We're going to add a build dependency, and that build dependency is going to be called bindgen. Alright, we're using the latest package. Now we are going to create build.rs, and this is basically telling it to take our fwasm.h header and convert it into Rust. So now that we have all that, we need to create one more file. We're going to go to source, new file. We'll call it fwasm.rs. We're going to include this. And right now you will see that everything is grayed out. It's because our project is not actually using it yet. We can go back to main rs, and we can do mod fwasm. Now when we go back to here, you can see that it's all used. Alright, so we're going to do cargo clean to get rid of our previous target. And then cargo build. Take a few seconds to build. You can see we have errors here because we're not actually including anything. We will add use. And then we should be able to build again. And you can see that we actually successfully built. Now one thing, Rust Analyzer is not very good at detecting if we're using no std. So in order to fix this, we are going to make a VS Code file. So come in here, new folder, .vs code, new file, settings.json. And then we basically tell Rust Analyzer not to check for all targets, and that our target is WASM32 unknown unknown. Come in here and we can see that the red squigglies are now gone. Alright, we're making progress. Okay, time to start with something basic. Let's flash some LEDs. Let's get rid of our boilerplate code and let's blink some LEDs. So let's start with a loop. We'll do index. We have 7 LEDs. And then we are going to call unsafe set board LED. Index will be the LED that we're going to do. It starts with 0, and that's the first LED that you can see blinking blue in the webcam right now as it picks up my voice. And then we have RGB colors, so I guess we'll just set this to red. And then we will do 250 milliseconds for the pulse, manager mode, and then we'll do LED pulse fade. This is going to allow the LED to pulse, and then it's going to fade out. Alright, then we're going to call exit to main app menu. When we are finished, this will just put us back on the main app menu that we see right now in the video. Okay. Cargo build. We're actually going to do a cargo build release. Let's build this release. Alright, now FWI serial L, let's just check to make sure the device is still there. It is. Now we can do cargo run -- release. And the project was started. Let's see here. Let's do it one more time. You see it flash for a little bit. It was pretty quick. So let's slow this down. Oh, we'll slow this down a little bit. Do 500 milliseconds. And we'll slow down the loop. Let's say 100 milliseconds. Alright, let's try this again. Cargo run. There we go. Now let's add a little bit to the console output so we can tell what's going on. We're going to do print int, which is currently not defined or imported. C setting LED. We're going to do print out color, print color normal, and then print out data type, print U at 32, and then we are going to take our index. Right. We need to give it a pointer. We've got to fix this import. All right. Need to unroll. Alright, cargo build release. And actually we're gonna take this off. We're not going to exit the main app menu. It's going to complain about that, but we're okay for right now. Cargo run, release. The prints aren't really visible when you run from the terminal or the shell over serial. It does not open it up. So if we go to scripts and then run this, we can see here that there's console output. It's probably kind of hard to tell on the camera, but it's just setting LED 0 through 7. Alright, let's clean up our code a little bit. Instead of doing unsafe on all of these, like that. There we go. And then we can hit Control Shift P and then format document. Another way to do it would just be to cargo FMT all. And it's complaining. Is that pulse? Oop, we need a semicolon here because we got rid of the unsafe block. Alright, let's try that again. There we go.